Yes folks, how are you going again? Hume here. So in this video we're going to talk about the circle. In fact, this is not the only video where we will talk about the circle. This video is the first of a series of videos where we will get into some of the properties of a circle, right? As you know, the circle is one of the shapes and figures of life in so many different ways. You look up in the sky, the sun during the day and the moon in the night. That is the circle already, all right? And in so many other facets and areas of life, you come across this thing that we call the circle. Now, we all know what a circle looks like. So in other words, we may not be able to spell out a dictionary definition if somebody asks us. If somebody walk up to us on the street and say, what is a circle? Oh, he'll be lost for words. But you'll recognize a circle if you see one. And you will even recognize a circle that's not so circle-ish if you see one. So in other words, many times in my sessions when I'm on the whiteboard, I will just try to draw a circle freehand. And most of the times my students end up laughing at me because generally it comes out looking more like a potato than a circle, right? But there are times when I get it really good, you know. And when I get it good, I just let them know that I get it good. You understand? So we know a circle when we see one. We could recognize a circle when we see one. But we may not be able to define a circle. So what I'm going to do in this video is discuss the properties of a circle. We're going to do it from a point of view of the word definition. All right? And then from the word definition, we come on the whiteboard and we demonstrate what it is exactly we're talking about. So you get an opportunity now to put some words to the face, so to speak. You know, we talk about putting a name to a face or a face to a name when we're talking about people. So in this case, we know what it looked like. We could recognize it when we see it. But we're going to start with the words and then make the link to the shapes and the figures. So in that way, we kind of deepen the understanding of this whole business of the circle. All right? Because these fundamental things, as simple as they may be, simple in the sense of basics, fundamental, step one, platform. Sometimes people don't get the gist of these things. And of course, like almost anything else in life, if you don't get the gist of the basics, the fundamentals, the step ones, then you'll definitely have problems going on to step 2 and step 3. All right? So, like almost every other thing in life, we start from the inside and we come out. So we're taking a philosophical stance on the thing now. All right? So we started from inside. We started from the inside of the circle. And we start by referring to the center. The center of a circle is the point equidistant from all points on the circumference. That sounds like something fancy, right? Well, we drill along to it. First of all, the spelling of center. Some people spell it C-E-N-T-R-E. Some people spell it C-E-N-T-E-R. What's the difference? Absolutely none. C-E-N-T-R-E is the British spelling, and C-E-N-T-E-R is the American spelling. It's like meter and meter. M-E-T-R-E is meter in England. M-E-T-E-R is meter in the States. All right? What's the big deal? No fuss, no fight. So Form 5 students, in case you didn't know, don't fight anybody over the spelling of the word center. And don't try to fight your teacher either. Right? And don't go in your lessons class and try to pick a fight with your lessons teacher because the lessons teacher spell center different to the way a teacher in school do it. These are the little inconsequential details. Just making a note of it. So the center of a circle is the point equidistant from all points on the circumference. Oy, oy, oy. Look trouble. Well, we know the center of the circle is the point in the center, in the middle. All right? So I have 3 circles on the board here. Let me use these 2 to demonstrate the center. This is the point. Well, what do we mean by equidistant? Equidistant means that it is equally distant. Right? Equi as in equal. All right? It is an equal distance from any point on this rim here. This is what we refer to as the circumference, which we come into in a minute. All right. Now the flip side of that is that the definition of a circle, the circle is defined as the locus or the path of any point or set of points that are equidistant from some particular point. So in other words, the circle itself is defined as being equidistant from the point. That point is the center. And the center is defined as being equidistant from the circumference of the circle. All right? That way, we start to put a little bit of words into something that we could understand from a conceptual standpoint. All right? The circumference. What is the circumference? The circumference is the circumference, not the circumference. The circumference is just our corrupted Trini pronunciation. All right? But the circumference is the enclosing boundary of a circle. A more familiar word would be the perimeter. So in other words, any other shape we could think of, we know that all the lines that enclose it, we refer to that as the perimeter. Whether we're talking square, rectangle, rhombus, triangle, parallelogram, or any combination of those shapes. The circle is so special that the perimeter of the circle has a special word for it that gets its own name. That is the circumference. So in plain language, the circumference of a circle is simply the perimeter of a circle. Or to say it another way, the perimeter of a circle is what we commonly refer to as the circumference. Right? So we okay there as far as the conceptual understanding is concerned. Right. So since we're talking circumference, the next thing we're going to discuss now is the, hold on. Yeah, let me deal with that one time. The circumference is the whole perimeter. All right? But if we take part of the perimeter, all right, let me say we take a portion. So we're no longer dealing with the whole perimeter now. This is just a part. So in other words, a portion of the circumference is what we refer to as an arc. The arc of a circle. Let me just flip through my notes here. Hold on. Right, I'll go into this in a particular order, right? So we know what the circumference is. The circumference is the whole perimeter. The arc is just a part of the circumference. Any portion of the circumference, doesn't matter what portion of it is, that is an arc, the arc of a circle. All right? Now I'm going to come back to this guy. Let me make it a little bigger. I'm going to come back to this guy here a little later on in the discussion, and you'll see where I'm going with that. But suffice it to say for now that this is the arc of a circle. The arc is simply part of the circumference. Nice. So after we discuss the point, the center, the circumference, and the arc, the next thing we're going to go to is this thing that they refer to as the chord. Chord, C-H-O-R-D, not to be confused with C-O-R-D. C-O-R-D is just a chord. That is something else. C-H-O-R-D is the chord of a circle. Not saying that you'll get a spelling test in a master exam, but you understand what we're trying to do. If you're talking about something, you have to talk about it properly. It's like when you're talking about somebody or you're referring to them by name or you're writing them a letter. You know, yes, when you want to spell people's name correctly, you want to pronounce people's name correctly. So in general, it is a good habit to be familiar with the spelling of these things as much as possible. Okay, nobody going to beat you over your head if you misspell chord, right? But if you could get the spelling correctly, you have absolutely nothing to lose and everything to gain. So the chord is a straight line segment whose endpoints both lie on the circumference of a circle. All right? The circumference of the line segment, those of you who would be more familiar with the the inner workings of my videos, right? My videos on coordinate geometry. I spent a lot of time discussing what a line segment is. I may or may not do a separate video on that, or I might just pull it out as an excerpt. But that's something else for a different discussion. The whole point of it is that a line segment is just a segment of a line, right? Right? A chord is a straight line segment. The line must be straighter. If the line is not straight, it doesn't qualify as a chord. A straight line segment whose end points both lie on the circumference of a circle. So this guy here is an example of what we refer to as a chord. Straight line segment meaning it is the segment of a line that we could extend infinitely in either direction. And the end of each end of the line segment lies on the circumference of our friend here. All right? So you get to see what it is. So anytime you have a line that cuts a circle, a line that where each end is on the circumference of the circle, that is a chord. Alternatively, we could say that a chord is a line segment joining 2 points on the circumference of a circle. So for example, if you have 1 point here and 1 point here, 2 points on the circumference of a circle, and you join those 2 points, right? Then that is a chord. All right? Nice. So we know what the circumference is. We know what the arc of a circle is. Right? We know what the center is. Don't mind the fancy vocabulary and thing. Right? You could always research that as often as you need to research it. Write it down and memorize it if you need to memorize it. But I am making sure and introduce you to the correct mathematical jargon, the vocabulary. Yes? Right, so we do circumference, we do arc, we do center, we do chord. Now, of course, if we're talking about chord, the next logical step is, no, before I go there, the tangent. We come back to the diameter just now. A tangent, and this now is where, we start to move into a different zone where the circle thing is concerned. All right? A tangent is a straight line that touches the circumference of a circle at a point, but if extended, does not cross the circumference at that point. All right? So in other words, you could describe a tangent as a chord where the 2 endpoints converge into a single point. Again, a little technical there, but all right. So let me use this circle as an example. That's a chord, all right, and that is a chord, and that is a chord, and that is a chord. So in other words, as you move this chord further away from the radius, the endpoints get closer together. All right? The 2 endpoints get closer together. And as you move this thing closer to the circumference, the endpoints become so close, in fact, that they actually converge into one single point. And at that point, you have what we refer to as a tangent. Now, of course, if you push the line any further out, it wouldn't be on the circle at all. All right? So the tangent, again, the tangent, forget that. Let me leave that out of this discussion. As the chord moves away from the center, you move and you move and move until you get to the finite, the outer limit of all the possible chords that you could possibly construct, like this. Parallel to this one, of course. And that is the tangent. Anything further than that, you're not even on the circle. So you could describe a tangent. No, let me leave that alone. All right? So that's the idea. So going back to the definition, it says that it touches the circle at a point. So the line touches the circle at a point, all right? But if you extend the line, it doesn't cut this circumference then. This chord here touches the circle at a point, and then you extend the line and it actually cuts the circumference. You cut the circumference, you cut the circumference. Same thing on the side. You cut the circumference, you cut the circumference, you cut the circumference, you cut the circumference until you get to a limiting point where you touch it, and when you extend it, it doesn't cut the circumference, it just continues on and out. Out! Alright? And that is where now, if you will allow me to touch into some physics now, we talk about going off on a tangent. Alright? So this is where, in using the vocabulary in connecting between maths and physics and irregular English, irregular usage, it allows you to visualize the thing even clearer and helps you to understand it and remember it better. So when we talk about going off on a tangent, right? If you have a slingshot and you're swinging this thing, right? You're flinging the slingshot, right? From the center here, and the string bursts, then the stone at the point where the string bursts will just continue traveling, and we refer to that as going off on a tangent. It will continue traveling in the direction that it was traveling at the point when the string breaks, and that will just go off in a straight line at a tangent to the original circle or the original curve. It doesn't have to be a circle, right? A circle is just one shape in a whole special series of shapes called curves. We have a whole other curves that, of course, wouldn't be part of the discussion here. But for now, we're just talking about circles. All right? And these principles are principles that we use when we launching ships in space and talking about gravity and all this kind of thing. All right, where you have the gravitational field, and then at some point the spaceship just sling off into space, and then they meet our next planet, and forget it. I just throw in that in just as a matter of general interest. But the whole point of what a tangent is, when we talk about going off on a tangent, there is a reason why we have that particular phrase. The phrase didn't just come out of nowhere. All right, because when you have a body moving around in a circle, and if for some reason the forces that keeping it in this circular motion are removed, it will just move off in a straight line. All right, that's more physics than maths, so don't worry about it if you're not familiar with it, right? It will move off in a straight line. That straight line is what we refer to as a tangent. All right, the definition we will go with here is just the line just touching the curve. It touching the curve, but it's touching the circle. I'm trying to be specific here now. It's touching the circle, but it's not cutting the circle. Big difference. The chord will cut the circle, which is what happens here, which is what happens here, which is what happens here. The tangent will touch the circle without cutting the circle. So in other words, the tangent will just graze the circle then, so to speak. It will just brush the circle, if you want to use that kind of language, so that it will allow you to understand the concept even clearer. All right, nice. Now, having gone to the outer limit of the tangent, we're going to go back inside the circle, and we discuss the case of the diameter. The diameter is simply a chord that passes through the center of the circle. That's basically what it is. All right, because if you take, let me consider the same class of chords here, right? And we run one through the center of the circle. It's still a chord. This line still meets all the previous criteria to be defined as a chord. Right? What's the definition again? A straight line segment whose endpoints both lie on the circumference of a circle, or a line segment joining two parts of the circumference of a circle. Right? The only difference is that this chord also passes through the center of the circle. And by virtue of passing through the center of the circle, the diameter is the longest possible chord. So in other words, the longest, the greatest possible length of a chord of any circle would be the diameter. You can't get a chord longer than the diameter. Because if you cross and you go on this side, you start getting, as you move away from the diameter, the length of the chord actually gets smaller. Alright? And the smallest value of the length of a chord is 0. That is when you have a tangent. Just a little technical language, don't worry about it. Right? Right, so let me see. Diameter. Right, so the diameter is a special chord. Alright, so in other words, if we could invoke the language of sets now, the diameter is a subset of the lines that we refer to as chords. Right? The diameters, and I mean you could have diameters anywhere in the same way that you could have chords anywhere. But the diameter is special in that it runs through the center of the circle, and by virtue of running through the center of the circle, it divides the circle into two equal halves. We will come to that in a while. And of course, once you're talking diameter, you know the next thing we're going to talk about is the radius. Yeah? So the radius is a straight line from the center of a circle to any point on the circumference. So you could have a radius here. 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 As long as the line starts from the center of the circle and goes to the circumference, that is a radius. In the same way, you can have a diameter here, or you can have a diameter there, or you can have a diameter there. The nature of the circle is such is that once the line passes through the center and it touches the circumference on the two opposite ends, that is what you refer to as a diameter. Now again, I want to take the opportunity to introduce some English, some language into the thing. And that is one of the nice things you get in my sessions. We mix it up with some language, because maths is about language. Alright, maths is about language. It's not just about numbers. It's not just about figures. It's about words too. So there's a particular phrase that we use, and maybe it's a phrase that people are not too familiar with, but you will hear it at some point. We talk about two things or two people or two entities or whatever it is being diametrically opposed to each other. Alright? Listen to that phrase. Alright? You talk about the opposition and the government being diametrically opposed on some point of policy or some idea or some bill or some part of a bill or something. The whole idea of being diametrically opposed is that you're opposed to each other at the greatest possible point of variance. Alright? Diameter is the longest chord. You can't get more opposed than that, because anything else you'll be opposed at a shorter distance until you get to the tangent where you're not opposed at all, where you converge and you're in agreement and you could go down the road. Alright? So anytime you hear the phrase diametrically opposed, think about the circle. Think about the diameter. Think about the fact that the diameter is the longest possible chord, the chord of greatest possible length. And so when we talk about being diametrically opposed, it means opposed in the most extreme possible way. You just can't get more opposed than that. Right, so you get a little English in the math session too, right? Couldn't want it better than that. So we're talking about chords and we're talking about diameters. The next thing we need to talk about, well, we discussed arcs as well. Chords, diameters, arcs, segments, and sectors. So we expanding the vocabulary now. Alright? So we have the chord cutting off. Well, the chord will cut the circle, right? A segment is a part of the circle cut off by a chord. Alright? Alright, let me use this one. We don't have the chord here already. This chord, in fact, let me say that before I demonstrate it. Any chord in a circle will divide the circle into two segments. Alright? The definition of a segment is a part of the circle cut off by a chord. But the very nature of the circle is such that chord will invoke not just one segment, but two. So, this chord will divide the circle into two segments. It will divide the circle into this segment here, this whole segment here, and this whole segment here. So, for example, if we have a chord, the chord will divide the circle into this segment in black here, and let me change the color, boy, and this segment here in red. Alright? I might need another circle, boy. So any chord that you can think of will by definition divide the circle into two segments. You will have a major segment and a minor segment. And of course, as you can guess, the major segment is the bigger segment, the larger segment is the smaller segment. Now, where the arc is concerned, the chord will also divide the circumference into two arcs. So you have this arc here in black, right? The chord, the two endpoints on the circumference will divide it into two arcs. This small arc here in black, and in red you have this big arc here. Right? Right. And of course, just as we had in the case of the segment, you have the major arc and you have the minor arc. So the chord is very important in the sense that it automatically, as soon as you construct a chord, it immediately divides the circle into two segments. It divides the circle into the major segment and the minor segment. It also divides the circumference into the major arc and the minor arc. That is something to remember, because you will have to interact with these kinds of terms and these concepts when you're dealing with circle questions at any level. Now, remember we said that the diameter is a special chord. So any concept that we could apply to a general chord, we could also apply to the diameter. The difference, of course, is that the diameter, colors real mixing up here, boy. The diameter by virtue of, let me use this circle here. The diameter by virtue of dividing the circle into two equal parts will divide it into two equal segments that we refer to as semicircles. So the diameter will divide the circle into two equal semicircles. Remember, of course, that the word semi refers to half. So the diameter, because it passes through the center of the circle, will divide the circle into two equal half circles then, semicircles. And we apply the same logic to the circumference. The diameter, by virtue of dividing the circle into two equal parts, will also divide the circumference into two equal parts, which we could refer to, I don't know if this is an actual word, but maybe we could refer to it as the semi-circumference. The semi-circumference, remembering of course that the circumference is the perimeter of a circle, and the semi-perimeter is an actual word in mathematics. So yes, we can refer to the arc, the curved part of the circumference of a semicircle as the semi-circumference, the semi-circumference, right? The semi-circumference. Yeah, we could refer to the semi-perimeter too, because this here is half of the perimeter of the whole circle. So this curved part here we can refer to as the semi-circumference the semi-perimeter, I'm just using the word semi to drive home the point that the length of this will be half of the length of the whole circumference, and that happens because the diameter cut the circle into two. It cuts the area of the circle into two semicircles. It will also cut the circumference of the circle into two equal parts. Semi-circumference, semi-perimeter, same difference. Now, that is not at all ever to be confused with the perimeter of a semicircle. The perimeter of a semicircle is the curved part plus the diameter. That is something that a lot of people leave out. Sometimes they will find the curved part and stop. No, 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 no. The perimeter of a circle is the entire circumference. The perimeter of a semicircle is half of the perimeter of the circumference plus the diameter. Make sure and get that distinction in mind, right? You know how they like to mix the shapes in the exams. All right? Minor arc, major arc, minor segment, major segment. Anything else we need to do? The sector. All right. Now, the sectors of a circle. Let me use some more vocabulary again. I will define it first. A sector of a circle is a plane figure enclosed by two radii of a circle and the arc between them. We know what arc is. We discussed that already. What about a sector? A sector of a circle is a plane figure enclosed by two radii of a circle and arc between them. Okay, so let me do this. We have a radii here. A radius, sorry. Boom. The plural of radius is radii, not radiuses, right? And we have another radius here. Boom. Another radius. So with this here is what we refer to as, that is one sector. Nice? And by definition, we would also have another sector, which would be this guy here. Alright? Now, what's the difference? The chord, sorry, don't mind, we're getting a little messy here now, right? Hold on, let me, yes, I think I could clear this and just draw an anyhow looking circle because we get the point. Alright, so I'm going to take the liberty of constructing a circle that may not look like a circle. Hey, we ain't come out so bad, man. Alright? Center. If we're talking center, we have to go more in the middle there, right? Yeah, that looking circly, man. Yeah, right. So, the chord, one chord, will divide the circle into a minor arc and a major arc. One chord will divide the circle into a minor segment and a major segment. When you have two radii, right? Two radii by definition mean that both of them coming out from the center of the circle. So you don't even have to worry about that. The very definition of radius means that it starts, well, at the one end of the radius will be the center, the other end will be the circumference. So anytime you have two radii would automatically divide the circle into two segments. Difference. The chord will divide the circle into two sectors. Sector is the area enclosed. What's the definition of the sector again? Sector and segment. Segments. Right. The segment is a part of the circle cut off by a chord. So in other words, the segment is the area defined by the chord and the arc between the two endpoints of the line segment, the two endpoints of the chord. So the two endpoints of the chord, they will cut off the circle in such a way that you have the arc, part of the circle, and the chord itself, that will define a segment. So in other words, the segment refers to the chord. Chords divide the circles into segments. A chord will divide the circle into segments. 2 radii would divide the circle into sectors. Alright? This would be your minor sector. This would be your major sector. Alright? So when we're talking about chords, we have the minor arc and the major arc. When we're talking about chords, we have the minor segment and the major segment. So let me write it out here. Alright? So this is segment and this is segment. Alright? When we're talking about 2 radii, that now gets us into another place where we're talking about sector here and sector here. Right? Minor, major, minor, major. Alright? So anytime, sometimes in questions you'll get a shape that looks something like this. You'll get something like that. Right? And they will tell you that that shape is the sector of a circle. Right? They will tell you that and then they give you one length. Let me say this length is 10 centimeters. If they give you a shape like this and they tell you that this is the sector of a circle, then you know immediately that this is the center of the circle. This is a radius. This will also be a radius, which means that this length is the same as this length, which means that this length is 10 centimeters. And after that, there's a whole lot of mathematics you could do to find the length of this arc and the area of the segment, and etc. and etc. and etc. The point I'm making is, very often in mathematics, like a lot of life outside mathematics, sometimes one word, one phrase, one sentence can give you a whole paragraph of meaning that will allow you to solve the question. It is not always the case that they will read and spell every single detail of a problem. Sometimes they use one word, and by the use of that single word, they expect you now as a student reading to understand what that means and to be able to translate that understanding into working the question. So anytime in a circles question and they use the word sector, you know immediately what that means. 2 radii, and this here is a fraction of the circumference. So with that information, you could also find the length of the whole circumference. You could find the angle here, and so many other things you could do just by virtue of that one word, sector. Alright? Segments are a little different, but when they use the word segment, you also understand that the curved part is part of the circumference of some circle. Right? And then you might be required to do other mathematics to find the center, etc., etc., etc. Alright? Now, when these 2 radii come out like this, so instead of them coming out at an angle like this, you could have one radii like this, one radius, sorry, and one radius like that. Now, this is the same thing as that. The only difference is that when the 2 radii extend at an angle of, well, this angle here would obviously be 180 degrees, right? So once you get into that zone of discussing the degrees, we know that a circle is 360 degrees. Once we are sure that this is a diameter, then it means, therefore, that we now have, in other words, the 2 segments are now equal. So we no longer have a major, sectors, right? Yeah, that's the problem. Sometimes they use the word interchangeably. Sometimes they use the word where you're not supposed to use it. That happens sometimes. But the... well, it turns out in this case it doesn't really matter. The sector, it was minor before, but because the 2 radii extend out into a whole diameter, it means that this sector is equal to this sector. Remember, of course, that we also discussed the fact that a diameter is a special chord. it means then that we could also consider this part as a segment and this part as a segment. So when the two radii actually extend out to become a diameter, that is where segment meets sector. That is where segment and sector merge and become one and become indistinguishable. At that point, there is no difference between a segment and a sector, because both of them become the same by virtue of the fact that we have a diameter. So two radii give you a whole diameter, which is just one chord that passes through the center of the circle. So at that point, sector and segment become one. Yeah? Right. So anything else we have to discuss? No. We didn't define what a straight line is. It's a different discussion. Maybe we could do a separate video on that. All right? So in this video, we just spoke. It wasn't brief by any stretch of the imagination, but brevity is not always possible. All right? And the one thing I will not do in my videos is promise brevity in every instance. All right? The challenge is therefore up to you, the viewer, to be engaged. Right? Whatever I could do, whatever I need to do will be done. But there's a certain line beyond which the responsibility is yours. Doesn't matter how exciting the topic is or how exciting the teacher is. If you don't decide to take in the information, you're going to come up with all kinds of excuses not to get it done. And if you're here at this point in the video, having followed from the beginning, then yes, by all means, we could do the work and we could do it. All right? So that is it for now where this particular video is concerned. And we're going to continue this series on circles with a series of other videos. We will talk about the formulae for area of a circle and circumference of a circle. We deal with parts of a circle where that is concerned. And then we'll deal with the further properties of a circle. We deal with angles, etc., etc., etc. All right? But before we could do all of that, you have to have the basic understanding of the basic. Sorry, you have to have an understanding. You have to have some level of comprehension of the basic properties of a circle. So, stay tuned, keep good, and come back again because we have plenty more coming. All right? Boom!